Problem 2 on practice exam 2 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. If we drop an object from rest near the surface of the Earth, the acceleration due to gravity is about 9.8 meters per second every second. The speed increases by 9.8 meters per second every second, ignoring air resistance. So after 4 seconds, it's going 39.2 meters per second. After 1 second, it's going 9.8 meters per second. After 2 seconds, it's going 19.6 meters per second. Part A, what is the infinitesimal change in the object's speed, dv, in the infinitesimal time interval from 4 seconds to 4 seconds plus dt? So right here at 4 seconds, we go over to the right an amount dt. How much do we go up? What's dv? What's dv? We go over dt at 4 seconds. How much do we go up? And if you haven't already thought about that for a long time, think about it some more. Stop the video and think about it. So, part A. Acceleration is dv dt, which is 9.8 meters per second every second. So dv is a dt. And the acceleration is 9.8 meters per second every second. So dv is 9.8 meters per second squared dt. The rate of change of the slope of this line is 9.8 meters per second squared. And that's dv dt. We just solved this equation for dv. Part B asks for how far does it go? What's dy, the distance it goes, in the infinitesimal time interval from 4 seconds to 4 seconds plus dt. dy is dv dt. Going vertically, so we're using dy. So v is dy dt, right? That's the definition of the speed, dy dt. How fast is it going at 4 seconds? That's what we need to know. The infinitesimal distance it goes at 4 seconds in dt is related to the speed. How fast is it going at 4 seconds? Well, it's going 39.2 meters per second. So we stick that in for v. So the rate of change of the position at 4 seconds is 39.2 meters per second. And that's dy dt. Solving for dy, 39.2 meters per second dt. Yes, this is hard because there's infinitesimals in there. It takes a long time to wrap your head around it. Once you wrap your head around it, it's pretty straightforward. The problem is it takes a long time to be comfortable with infinitesimals. Part C. Consider the infinitesimally thin rectangle drawing at 4 seconds. So let's put it on the graph. There it is. Write an equation for the area of this rectangle. The height is just v, the speed. What's the width? What's the width of this thing? It's dt. It's dt. So the height is v, and the base of this rectangle is dt. And at 4 seconds, we know the speed is 39.2 meters per second dt. What does this represent? v dt. What does the area under a v versus t curve represent? It's just how far it went. So this is dx. The area of this rectangle is dx. v dt. That's problem 2.